Alright, this video is on dividing exponential expressions. So suppose we have x to the fifth divided by x squared. Okay? So we know that the numerator x to the fifth, that really means x times x times x times x times x, right? 5 x's multiplied together. And the denominator, x squared, and we just have x times x, right? We're just kind of writing it out the long way. You know what x to the fifth represents and what x squared represents. Now, all this is multiplication in the numerator, all this multiplication in the denominator, and we've got some common factors here we can divide out, like this and this divide away to 1, right? Because the same thing divided by itself is 1. And then we have this one and this one, that leaves 1 as well. Right? And then there's nothing else in the denominator, just a 1 is left behind in the denominator. But in the numerator, we're left with what? Well, we're left with x to the third, right? It's really x to the third over 1, but we just write it as x to the third. Right? So x to the fifth divided by x squared goes to x to the third. So what's the relationship between our original expression, x to the fifth divided by x squared, and its result, x cubed? Well, you're right, we're subtracting the exponents. So let's write that up as a note. All right, so to divide exponential expressions that have the same base, that's the key, they have to have the same base, then we keep the base and just subtract the exponents. And we end up subtracting them, the top exponent minus the bottom exponent. You know, in math language, it looks like this, b to the m divided by b to the n. So you have the same base. We're dividing two things that have the same base. And we keep the base, and then we do top exponent minus bottom exponent. Make sense? All right, then let's try a couple of examples. All right, so this first one, we've got x to the seventh y cubed over x to the fourth times y. All right, well, we've got x to the seventh divided by x to the fourth. Those are being divided. So we can do x to the 7 minus 4. And then we've got y to the third divided by y. All right, so what's the exponent on the y down here? That's right, it's understood to be a 1. Don't forget that. So we really have y to the 3 minus 1. And all that goes to x cubed, y squared. Right, ready to see that? And it doesn't matter if we use variables or if we use numbers. The catch here is that you're dividing two things that have the same base. So in this case, the base is 7 here in number 2. Right, so we keep the base and subtract top exponent minus bottom exponent. So 8 minus 2 is 6. So this goes to 7 to the 6th power. You follow me? Right, and then this third one, 3x squared y is the base up here in the numerator for the 5, and x cubed y squared is the base for the 2 in the denominator. All right, so they're not the same. So we need to see if we can figure out a way to simplify the numerator and the denominator separately. Right, well, looking at the numerator, we know that we have a product raised to an exponent. So we remember that from previous knowledge. And so the exponent on the 3 is a 1. So 1 times 5 is 5. And then x squared to the fifth. So we multiply the 2 and the 5 together to get x to the 10th. And then y to the first to the 5th power. So 1 times 5 gives you 5. Okay, so that's the numerator. And that's one of the previous properties we've learned. And the denominator down here, we have x to the 6th, because 3 times 2 is 6, and 2 times 2 is 4, so y to the 4th. All right, so we have to do that property first, and then we say, all right, do we have anything else that we can do? All right, well, we'll leave 3 to the 5th alone, because there's nothing in the denominator to simplify that. But then we have x to the 10th divided by x to the 6th. And notice this is one product in the numerator and one product in the denominator. We're not adding terms here yet. All right, we'll get to that in a little bit. All right, so x to the 10th divided by x to the 6th, the base is the same. We keep the base, subtract top exponent 10 minus bottom exponent 6 gives us 4. Then we have y to the 5th divided by y to the 4th. All right, so we keep the base and subtract top exponent minus bottom exponent, so y to the 1st. We don't need to write that. And that's all over 1, so we just leave it like that. That's as far as we go. So 3 to the 5th, x to the 4th times y. All right, so I got one more example I want to do. x plus 3 to the ninth over x plus 3 to the fifth. All right. So the base here is x plus 3 for both the top and the bottom. So we keep the base the same, x plus 3. And we subtract top exponent minus bottom exponent. So 9 minus 5 is 4. So all of this goes to x plus 3 to the fourth power. All right, so again, it doesn't matter what the base is, it's just that the base has to be the same with the top and the bottom. All right, so if you're dividing expressions and they have the same base, then you keep the base and do top exponent minus the bottom exponent. All right, that's it. Study well. Please let me know if you have any questions.